Hello all, welcome to this video. For those who are new, this is a project for our Data Science Master in University of Malaya. This is the final video for this video series, and I'll quickly go through everything again, just as a brief introduction, and then we'll go into the main point of this video, which is the deployment of our app, and I'll show you what I have for that app. Okay, for this project, we are actually predicting the crude palm oil commodity price and also the production yield prediction using the climate data as well as news title sentiment. So the introduction, Malaysia is actually the largest derivative market for CPO, which stands for crude palm oil. And on the figure right here, you can see that Malaysia and Indonesia feature here. That's because Indonesia and Malaysia makes up 87% of the entire production market cap for CPO. And you would imagine if anything affects this region, like climate, it will affect the production yield of the plants and indirectly affect the supply of CPO and the prices. That's the logic. So the motivation is to basically, we read some paper about the effect of climate on production yield. Then we just want to test the hypothesis whether climate data will affect or correlate to palm oil production yield, as well as we want to find out whether new sentiments related to palm oil industry will affect the CPO prices. The general workflow is split into 5 milestones, which is the 5 videos we have for this video series. It started with data acquisition and web crawling, and then the second part is like data warehousing and data lake, just for exposure. And after that, we do data cleaning, we interpret the data and deploy finally an mobile app. For data acquisition, we get our data from four main websites. Investing.com is where we get our trading data on CPO prices for Bursa Malaysia market. Tutiempo.net is where we get all the weather data for Malaysia and Indonesia, and it has more than 80 weather stations where we can get this data on a daily basis. MPOC.org.my is where we get our Malaysia CPO production yield from 2014 to 2020. And the last one is the news titles, where we get it from theedgemarkets.com with a keyword that's related to palm oil. So we use Scrappy and Selenium for this task. As I said just now, data warehouse and data lake is just for exposure. We tried putting data in and accessing the data lake or data warehouse for queries. So that's just for exposure. But the next part is we do data cleaning. Basically, we transform a script news title into data frame. We vectorize it, tokenize it, do some TF-IDF, and do new sentiment analysis on it. And also, we standardize data type. We remove irrelevant columns and handle missing values. Like for example here, we have the weather data, and there are a bunch of missing values that we need to impute good data into those missing data. But something like 90% missing is just a lost cause, so we remove them. The rest by using a KNN imputation. Okay, for interpretation, here you see this chart right here is temperature data. You can see that it's very seasonal, and as well as you can look at here, the bottom part. There's a bunch of charts here, but these are mostly price action. You can see a price, and then you have also like the month and day of week attributes. And down here are the moving averages of price, volume, as well as the change of price. And the last ones here, the 5 down here, this one is a production change from the CPO, and the last 4 is actually the sentiment from the news title. So you have the positive, the negative, the neutral, and the compound, which is like a combination of them. So we did prediction on CPO price and CPO yield. We look at the feature importance by using permutation importance. And for CPO price prediction, the features that are important are nonetheless the price itself. The other features does not seem to be so relevant for this prediction. As for the CPO yield prediction, we can see that the month attribute is actually most important. The next will be like the precipitation and humidity attributes, signified by the PP and H here. Most of them are PP or H. And the suffix here are just the weather stations. For the prediction part, for CPO price prediction, we are using an LSTM model. And we have two dropout layers, like one within the LSTM itself and another after the dense layer. This is to be able to propagate the weights longer so that the training can learn a better representation and it doesn't overfit on the training data so quickly. So this was done using TensorFlow, and as you can see, 2/3 of the data are trained and 1/3 of data is actually used as a validation set. From this chart, you can actually tell that the predicted data are closely following the actual data, so which is a pretty good indication that the model works. Okay, the final part of this is the app deployment. Since I'm limited to Kivy app deployment, I'm going to deploy it on Windows. My thinking was to basically bundle everything we have learned for this course and be able to do it within this app. So everything we have done for this project, like crawling, charting, processing, training, and predicting, are all coded in this app. And from this screen here, this is actually how it's going to look like. Without further ado, let me show you the app. Alright, so I have actually created a shortcut here. This app is done using Kivy and installed into a window execution file by PyInstaller. And let me click it. It will start the terminal. Let me bring it to this screen. Okay, so what you see here is basically how it's going to look like. You have an interface where the user can go in and put in a company name, the interval where they want to train the data. The company name is actually from investing.com. So I'm only getting it from the historical data. So if the user wants to get any data from investing.com, it must use only the company name or the commodity name of the historical data link here. So for example, if I want to get for Sime Darby Plantation, I will go to Sime Darby Plantation main page and click on the historical data and look at how it is called here. So I will follow this format for how I'm going to put it into my app. Right, so I put Sime Darby Plantation here and I select at least 2 years, at least a year of data, because otherwise it won't learn very well. Okay, let's just put 2018 and I just put like yeah, something like this, right? At least 2 years of data here. So what it do, it will run Selenium at the back end with a Chrome browser, Chrome driver. You crawl the data directly from investing.com. It will take some time because it's 2 years of data, and the longer interval you crawl is going to take longer. But it will only take long on the first time because it will actually store the data in the folder. So this was actually where the execution file was, and within this there is a folder called data where it's storing the dataset here. So as it is crawling, we will see Sime Darby Plantation pop up here as a new file, because then it's going to be storing it inside here. This will take some time, so we just wait a while. awkward silence, but it's good. Um, yeah, so there are plenty of stuff you can do with Kivy. Like you can, make it to have a pop-up, and if the user wants to abort it, he can abort it. I'm not gonna click it because they will cancel the process. Let's wait. There we go. So it has crawled the data. It took like maybe 2 minutes, let's say. And once it has crawled the data, it will read the data and it will give you a chart, technical chart, a candlestick chart, right? So you have all the stuff here, like the prices, the close prices, the high, the low of that day, as well as like moving averages and the volume down here. And you have the RSI as well as the MACD. So having a chart is not good enough. You actually want to run prediction to be able to predict the next few days, because that's what you want to do if you are trading, to see if the price is going to go up or down for the next few days. So you run prediction, and what this do is this will train real time and give you a real time training and validation loss plot. I have a early stopping mechanism here where if the training loss does not improve for 20 epoch, then it will stop. So, okay, now what it tells you is basically it has trained on 2/3 of data set and give you the 1/3 validation prediction here. And this is one way where you can validate whether the model has performed relatively well. And it's not bad, right? It's following all the major trends. But what we want to do next is with this, if we are confident with the model, we want to look at the prediction. And here is using 20 days past history to predict the next future 5 time steps. And here we can see that the price is gonna, be around 5 ringgit for the next 5 days at like slightly low downtrend. So this is what the app can do, and I will put this on the GitHub, but I will not put the executable folder in the GitHub because it's 4 gigs. So I'll put all the codes, the dependencies, as well as the PyInstaller specs file, so you could actually try to install it yourself, and hopefully it works on your machine. Alright, so that's all for me. I hope you learned something today, and I hope it helps you in some way. Alright, thank you.